linear inequalities and absolute value inequalities. There are four inequality symbols: less than, greater than, less than or equal to, and greater than or equal to. Just like if we see an equal sign in a problem, we know it's an equation. If we see one of these four inequality symbols, we know it's an inequality. So to solve an inequality, we're going to get the variable by itself on the left-hand side. For instance, x is greater than -3. But then we're going to graph it on a number line as well. Sketch a number line. We're going to have our endpoint -3, and then also 0 is a good reference number to have on a number line as well. At the endpoint, -3, we're going to have an open or closed circle. The inequality sign will tell you whether it's going to be an open or closed circle. If the inequality sign is less than or greater than, you're going to have an open circle. If the inequality sign is less than or equal to or greater than or equal to, it's going to be a closed or shaded in circle. So in this case, x is strictly greater than -3, so open circle at -3. And then all the values greater than -3 lie to the right, so we're going to show an arrow pointing to the right. And finally, we're going to write the final answer in interval notation. Interval notation has to have a beginning value followed by an ending value. So the solutions here begin at -3. And go to positive infinity. And then we're going to have either a parenthesis or a bracket at the beginning and the end of the interval. A parenthesis means that endpoint is not part of the solution set. It means the solutions get infinitely close to it but don't actually reach it or touch it. A bracket means the endpoint is part of the solution set. So in this case, next to the -3, we're going to have a parenthesis because -3 is not greater than -3. So it's -3 itself is not part of the solution set, and we always have a parenthesis next to infinity, positive or negative infinity. So let's look at another example. If we solve the inequality, we might come up with x is less than or equal to 5. If we graph that, of course, we need 5 and 0 on the number line. In this case, values of x are less than or equal to 5, so we're going to have a closed or shaded in circle, and all the values less than 5 lie to the left in this case. So interval notation, the solutions keep getting smaller and smaller, so we'll simply state they begin at -infinity and go to 5, parenthesis next to infinity. In this case, we have a bracket next to the 5. Since 5 is part of the solution set, 5 is less than or equal to 5. Which brings us to solving a linear inequality. There's actually 3 linear inequalities we'll be reviewing here. The first one, just a plain linear inequality, just like a linear equation. All the variables have an exponent of 1. They're just one inequality sign in the problem. So we solve it basically using the exact same steps as solving a linear equation. But anytime you're working with an inequality, there's one rule you have to keep in mind. If you multiply or divide both sides by a negative number, you have to remember to flip that inequality sign or take the opposite inequality. We're also going to be solving compound inequalities. Compound inequality is basically two inequalities combined into one. For instance, 2 is less than x is less than 11. It's two inequalities combined into one, and notice x will always be in the middle, in between the two inequality symbols. And then OR inequalities. OR inequalities is two inequalities linked together with the word OR. For instance, x is greater than 5, or x is less than or equal to -1. So we'll begin looking at just a plain linear inequality. So solve it using the same steps as solving a linear equation. Simplify each side. So in this case, we have to distribute that, -5. Combine like terms. Get all your variables on the left-hand side. And then isolate that variable, getting rid of any addition or subtraction first. So subtract 15x from both sides, and then divide both sides by -4. And here we're dividing by a negative, so we have to flip that inequality sign. Less than is going to become greater than. So we solve the inequality. X is greater than 3/2. We want to sketch it or graph it. Open circle at 3/2, and the solutions lie to the right. Interval notation. All the values from 3/2 to positive infinity, not including 3/2, so parenthesis. Example 2, A compound inequality you recognize because you have two inequality symbols in one problem. So we want to isolate the variable in the middle, begin by getting rid of any addition or subtraction. So the opposite of adding 7 is to subtract 7. But since there are 3 parts to a compound inequality, we have to do or perform each operation 3 times, to the left, the middle, and the right. And then divide everything by 3. Now we're dividing by a positive 3, so it's not going to change the inequality symbols. And at this point we solve the compound inequality. Graph it on a number line. Close circle at -5, open circle at 7. Interval notation, the solutions from -5 to 7, including -5, but not including 7. And example 3. Two inequalities linked together with the word OR is an OR inequality, so just solve each inequality. The first one, add 4 to both sides. X is less than or equal to -3. Or the second inequality, add 8 to both sides. X is greater than or equal to 7. Graph each inequality on the same graph. All the values less than or equal to -3. All the values greater than or equal to 7. And then now we see from the graph that the solutions are basically broken up into 2 different parts, which means we're going to have 2 intervals when we write the final answer in interval notation. All the values less than or equal to -3, all the values greater than or equal to 7, not forgetting that word OR in between the 2, and we have a notation or a symbol that stands for OR. It's called the union symbol, looks like an OR. So this is how we would write the answer in interval notation. Which brings us to solving absolute value inequalities. Pretty easy to recognize. You have an inequality symbol in the problem and an absolute value. So the first thing we want to do is isolate the absolute value on the left-hand side. And then we're going to drop the absolute values depending on whether that inequality symbol is less than or equal to, greater than or equal to. If the inequality sign is less than or equal to, we drop the absolute values by rewriting it as a compound inequality. If this inequality symbol is greater than or equal to, we're going to drop the absolute values by rewriting it as an OR inequality. And then you just solve the remaining problem. So let's look at example 4. You see an inequality symbol, you see an absolute value, so absolute value inequality. In this case, step number 1 is already done for us. The absolute value is already isolated on the left-hand side. So now we want to get rid of it. Look at the inequality symbol, it's greater than, which tells us we're going to drop the absolute values by rewriting this as an OR inequality. 2 inequalities linked together with the word OR begin by just dropping the absolute values for the first inequality. The second inequality, the left-hand side, still remains the same, the side that had the absolute value. The right-hand side, though, you're going to multiply by -1. So 1 times -1 simply gives us -1. And since we multiply by negative, we have to flip that inequality sign. So we got rid of the absolute values. We just need to solve this OR inequality now. Add 4 to both sides. X is greater than 5, or X is less than 3. Graph it. And write the answer in interval notation. Example 5, another absolute value inequality. In this case, the absolute value is not isolated on the left-hand side, so that's the first thing we need to do. Now we cannot just distribute that 4 into the set of absolute values. You can't move something into an absolute value, you can't pull something out, so what we're going to do is move it to the right-hand side. Opposite of multiplying by 4 is to divide by 4. Now the absolute value is isolated. Now we want to get rid of it, the inequality sign less than or equal to in this case, which tells us we're going to drop the absolute value by rewriting it as a compound inequality. So begin by just dropping the absolute values. Now compound inequality, of course, has 2 inequality symbols and the variable is always in the middle, so whatever inequality symbol you already have, write it again out in front, and then whatever's on the right-hand side, 4 in this case, we're going to multiply by -1, and that -4 will then go at the beginning of the problem. So now we have a compound inequality. Solve it, getting the variable by itself in the middle, so add 5 to the left, to the middle, and the right, and divide everything by 3. graph it, and write the answer in interval notation. Example 6, another absolute value inequality. Step number 1 once again is done for us. The absolute value is already isolated on the left hand side. So drop the absolute values by rewriting it as a compound inequality once again, because that inequality sign is less than or equal to. So drop the absolute values, carry that inequality sign out in front again, and multiply that 5 by -5, by -1, giving us -5. Solve the compound inequality. Subtract 8 from the left, the right, and the middle. Oops. That should be just 8, not 8x. But right now, we still haven't solved the compound inequality. Anything that's negative is actually being multiplied by a -1, so that get rid of a multiplication -1, we need to divide everything by -1, which of course is going to change those inequality signs in the process. So at this point, we have solved the compound inequality. Graph it, and write this answer in interval notation. And example 7, another obviously absolute value inequality. Have a little bit of work in order to isolate it. Get rid of that positive or plus 19 first. Subtract 19 from both sides. And then divide everything by 2. So we completed step number 1. We isolated the absolute value. And at this point, you should notice that there's not going to be any solution to this inequality. We know that an absolute value can never be equal to a negative number. So if this would have been the absolute value of 2x plus 10 is equal to -4, right away we know that's no solution, because any absolute value is going to be positive, and a positive number would never be equal to a negative number. Well, in this case, same general idea. Absolute value is always going to be positive, and what's this telling us? That a positive number is going to be less than a negative number, which of course is impossible as well, so that's going to be no solution. However, if the inequality sign would have been greater than or equal to, for instance, the absolute value of 2x plus 10 is greater than -4, anything you substitute in there for x will be a positive number, and all positive numbers will always be greater than -4, so that would have been all real numbers or infinitely many solutions.